This lecture will introduce database and data security concepts. We will look at security issues. We will talk about ways we can use to secure databases and data, such as encryption, authentication, and authorization. Lastly, we will look at database audits. Why should we protect data? Data is a valuable resource. It should be protected like any other company asset. Many successful companies have made important business decisions based on data analysis. Therefore, data could be of strategic importance. In addition to ethical and policy requirements, there might be regulatory requirements dictating data protection. If we want to ensure system reliability, we'd better protect databases and data. When we deal with security, we should not just focus on external security threats. Though whenever there is an external security incident, it's high profile, it could cause intangible damages, it could damage business reputation, but actually there have been more internal security threats than external security threats. Therefore, we should focus on internal as well as external security threats, unintentional as well as intentional security threats too. There are two ways to secure databases and data. Discretionary access control (DAC) has been implemented industry-wide. The SQL standards fully supports discretionary access control. In some very rare, highly sensitive environments, a more restrictive control may be required. In those situations, mandatory access control (MAC) may be used. With mandatory access control, the database objects that we want to protect are assigned a security class. Users will be given security clearance. We have rules regulating classification and clearance. This diagram describes modern computing environments. In modern computing environments, we have many components. We have hardware, software, people, and communication networks. Each of those components may have potential security threats. Keep in mind, when we deal with security, we should not just focus on external security threats. There have been so many security incidents related to internal inappropriate IT policies and insufficient user training. There are many ways to secure databases and data. Encryption is commonly used. Generally speaking, with encryption, we apply an algorithm with a key or two keys to protect data. The algorithm may be based on bit manipulation or mathematical functions. We will learn more about encryption next. Data encryption standard (DES) is one of the early encryption standards. With DES, we use bit manipulation. Two commonly used techniques: substitution and permutation. With DES, data is encrypted to blocks of 64 bits. Advanced encryption standards, AES, were developed after DES. With AES, the data is encrypted to 128, 192, or 256-bit blocks. Because the block sizes are larger, AES standards are more secure. Public key encryption has become more and more popular. With public key encryption, there are two keys, not like with DES and the AES, there's only one key. With public key encryption, we use mathematical functions instead of bit manipulation. With public key encryption, the private key is used by data owners to encrypt data. The public key is used by data consumers to decrypt data. RSA is one of the early public key encryption standards. Digital signatures are being used more and more in today's e-commerce. Digital signatures are based on the public key techniques. Digital signatures are just a stream of symbols. Digital signatures are different and unique for each and every e-commerce transaction. Every year, when we file our federal income tax return, we use our last year's adjusted gross income as part of this year's digital signature. This is one of the reasons digital signatures can be made unique for each and every year. Most likely, our adjusted gross income numbers are different for each and every year. Another method commonly used to secure databases and data is authentication and authorization. Generally speaking, database users must be authenticated by database management systems first. Once a user is authenticated, the user can use the data stored in a database based on the user's authorization. Let's use SQL Server as an example. There are three important concepts about SQL Server authentication and authorization: principals, securables, and permissions. Principals are just like you and me, users who need to use the database. Securables are the things that we want to protect, like database tables and databases themselves. Permissions are about what a user can do with a securable. Permissions could be read or write. With SQL Server authentication, it could be Windows authentication or SQL Server authentication. Windows authentication is based on Windows network. It's related to Active Directory of the Windows network. SQL Server authentication is self-contained within the SQL Server itself. Also, with SQL Server 2012 and beyond, there is a new feature, contained databases. With contained databases, users can be authenticated and authorized by the content databases themselves without going through an instance of SQL Server. This provides the portability especially required by cloud computing environments. Role-based access control is a very important permission management technique. For instance, if we have 100 workers in the accounting department that we need to assign permissions to, there are several ways to do that. One way is that we can assign permissions to the 100 users one by one. By doing that, we need to assign permissions 100 times. An alternative is that we could create a security role. Then we put the 100 users in the role. Then we assign permissions to the security role just once. By doing that, we can significantly cut down the overhead for permission management. It's also a better and a cleaner way to manage permissions. This is another way to look at modern distributed computing environments. We have remote users sending encrypted data requests to servers located at a data center. When the requests reach the data center, the requests are decrypted. The database will authenticate the user and will determine what the user about the data stored in the database based on the user's authorization. The results are returned to the user via the reverse route. Database audits are a very important practice. Depending on internal or regulatory requirements, sometimes we need to know what happened in our database. Database management systems keep a log about all the activities for a database. When we conduct a database audit, we will review the log to determine what happened in the database, who did what, and when. If a log is used primarily for auditing purposes, the log is called an audit trail. This concludes the lecture on database and data security concepts.